All right, so the Mod 11 qualifier, well, it's the practice for the Mod 11 test. I did the front side in a previous video, which I've attached the link to, and now I'm going to do the back side of it. I'm going to do it on separate paper just so that I have extra room to write. So, here we go with number 18. Number 18 says, let me get my camera straight here, 4 radical 2r plus 1 equals radical r plus 18. Now, as long as one of my radicals is by itself, I can go ahead and square both sides. So, when I square both sides, I need to remember on this side that the squared also has to apply to the 4. Now, a lot of people made mistakes because they called this 4 times 2. It's not 4 times 2, it's 4 to the second. And then my parentheses, because the radical will cancel, 2r plus 1. Over here, my radical cancels, and I have r plus 18. So I have 16 parentheses 2r plus 1 equals r plus 18. I'm going to do some distributive property. That gives me 32r plus 16 equals r plus 18. Getting my r's together, I'm going to subtract r. 31r plus 16 equals 18. Move that 16. 31r equals 18 minus 16 is 2. And I get r equals 2 over 31. Yes, this answer is completely ugly, but let's check it out and see if it works. Remember, when do I need to check my answers? I need to check my answers when I have I'm going to change colors just so it doesn't match. When we have an even index, no index written means it's an index of 2, so I do need to check my answers. So I'm going to check and see, does 4 times the square root of 2 times r, which I'm saying is 2 over 31, plus 1, does that equal the square root of 2 over 31 plus 18? Now, I'm going to do this on my calculator because it's going to get ugly. So, 4 radical 2 times 2 divided by 31 plus 1. And all that needs to be under the radical in your calculator. If you're using, grab it one like my pink calculator, show you how it has to look. I would have 4 times the square root of 2 parentheses 2 divided by 31. Now this parentheses that I close is going to close the fraction. Then I put the plus 1 and then I close the other parentheses. That closes my radical. So I've got parentheses around my fraction and parentheses around what's under the radical. And I get this 4.25023 blah 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 blah. Okay, I don't really want to write that down, but I do want to see if that's the same as this, then I'm good to go. So I'm going to go on the next one, next line here. I'm going to do the square root of parentheses 2 divided by 31 plus 18. Notice it's all under the radical there. Now here it's easy to see that it is the same thing because, it's all on a glare for you, but because, oh, go away glare. Because you can see the digits right there, 4, 2, 5, 0. You can see that they match exactly. How can I tell that on here? Well, don't clear anything. Just do the square root, hang on, square root of parentheses 2 divided by 31. Yes, I opened another parentheses, even though they already opened one, because I needed a separate parentheses for my fraction. And I get this 4.250. How do I check to see if that's the same decimal as before? Well, I should be able to just arrow up and hit enter, and that was the previous answer right there. Okay, so it does check out. It's an ugly answer, but it is what it is. Okay, number 19 says 36 equals 20 plus 2 radical 15n plus 4. So I only have one radical this time, but I do need to get it by itself. So the first thing I'm going to do is subtract 20. 36 minus 20 would be 16 equals 2 radical 15n plus 4. can't square both sides yet. I need to divide by 2 in order to get rid of that guy. 16 divided by 2 is 8. And then I have 15n plus 4. Now I'm ready to square both sides. Why am I squaring it? Because we have an index of 2, which also means we're going to need to check our answers. 8 squared is 64. Squaring the square root gives me 15n plus 4. I'm going to subtract 4. 60 equals 15n. Divide by 15. And n equals 4. Going to check my answers. So coming back to the beginning, I want to see, does 36 equal 20 plus 2 radical 15 times 4 plus 4? Well, I think I can check this one by hand. 20 plus 2 radical 15 times 4 is 60 plus 4. Not plus, but that should be equals. 20 plus 2 rad 64. What is the radical of 64, or the square root of 64? That would be 8. So, can't write and talk at the same time, sorry. 20 plus 2 times 8. So does 36 equal 20 plus 16? Sure does. So my answer of n equals 4 is a good answer. Okay. So there's 18 and 19. Moving right along, number 20 says the square root of 65 minus 5n equals n minus 3. Is my radical by itself? Yes, the only thing on this side is what is in the radical. So I'm ready to square both sides. So I'm going to square there and square there. This side's easy. The radical cancels. I have 65 minus 5n equals. How do I square a binomial? Well, I'm going to have to write it as n minus 3 times n minus 3. I have to write it twice. So as I distribute, I'm going to get n squared minus 3n plus 9. Combine a bunch of like terms here. Minus 5n equals n squared minus 6n plus 9. And at this point, I need to get everything to the same side as the n squared so that I can factor. So I'm going to add 5n, because those guys are like terms. I'm also going to subtract 65, because those guys are like terms. And that leaves me with my 0 over here equals n squared minus n. And 9 minus 65 gives me minus 56. So I need to factor this. You can snowflake if you want, or you can just do it the shortcut way if you know that way. Negative 56 and negative 1, I think it's 7 and negative 8. I have n plus 7 and n minus 8. So I get answers of n equals negative 7 and n equals positive 8. Do I need to check my answers? Yes. Index was even, so I do need to check them. So I'm going to check negative 7 first. Does the square root of 65 minus 5 times negative 7 equal negative 7 minus 3? Well, negative 7 minus 3 is negative 10. Over here, I get 65, and negative 5 times negative 7 is plus 35. So I get the square root of 100 is equal to negative 10. Is that true? No, the square root of 100 is positive 10. Does not check out to equal negative 10. Okay, now I'm going to check out the 8. Does the square root of 65 minus 5 times 8 equal 8 minus 3? Well, let's see. 65 minus 5 times 8 would be 40. Does that equal 5? What is 65 minus 40? 25. Does the square root of 25 equal 5? That one does. So that one does check out. My only valid answer is n equals 8. Okay. Number 21. 3 times the cube root of x minus 2 is equal to the cube root of 20x plus 16. Now am I going to need to check my answer on this one? No. Why not? My index is odd. 3 is an odd number, and that's my index, so I don't need to. I do need to remember that I'm not just squaring both sides, though, this time. I'm going to cube both sides. Because that index is 3, that's the only thing that'll cancel out that radical. Just like the first one I did, I do need to apply that to the 3. So I end up with 3 to the 3rd power. And then it's going to cancel out the radical. So I have x minus 2. And over here it cancels out the radical. So I have 20x plus 16. 3 to the 3rd power. Most people would get this wrong by saying it's 9. It's not 3 times 3. It's 3 times 3 times 3, actually, which is 27 times x minus 2 equals 20x plus 16. That gives me 27x minus 54 equals 20x plus 16. I'm going to get my x's together by subtracting 20x. And let's see if it's okay. In the same step, I'm going to add 54 to move that guy over here. So I have 27 minus 20 is 7x. And 54 and 16, that would be 54, 64, that would be 70. Divide by 7, and x equals 10. If I wanted to check my answer, I would plug it back in. Does 3 times the cube root of 10 minus 2 equal the cube root of 20 times 10 plus 16? Well, that would be 3 times the cube root of 8, which is 3 times 2, because the cube root of 8 is 2, which is 6. Over here you would have 20 times 10 would be, 200 plus 16. So in other words, the cube root of 216. And if I go to my calculator and I type in the cube root of 216, guess what? It's 6. So it does check out, and you always can check out your answers on odd problems if you choose to do so. Okay? Always a smart idea when you're taking a test to check those ones as well. All right? Now on to number 22. X plus 6 equals square root of 6x plus 52. This one is actually just like, which one is it? Number 20. If you look at your paper, number 20 and number 22 are almost identical. The only difference is the radical's on the left here, it's on the right here. But I'm ready to square both sides. So I'm going to square them. And over here I'm going to have to remember to do x plus 6 and x plus 6. Over here I will just have 6x plus 52. So here I get x squared plus 6x plus 6x plus 32 equals 6x plus 52. And x squared plus 12x plus 32 equals 6x plus 52. Now, just like before, I need to move everything to the same side as the x squared so that I can factor it. So I'm going to subtract the 6x to move it over. I'm also going to subtract the 52 to move it over. So I end up with equals 0 on that side. Over here I have x squared plus 6x and 32 minus 52. 32 minus 52 is negative 20. So if I factor that, if I use my snowflake, I have negative 20 and 6. Two numbers that multiply to get negative 20 and add to get 6. Okay, so I'm wondering why this isn't working it out. Way back here I had an error that I'm sure you probably noticed. 6 times 6 is not 32, it's 36. How about that? So that means if this is a 36, what's 36 minus, that's, 36 minus 52. 36 minus 52 is actually negative 16. So this shouldn't be negative 20, it should be negative 16. So if I change that, I believe I have 8 and negative 2, and now I have something that works out well. Come on, Franken, do your multiplication. All right, x plus 8, x minus 2 equals 0. So I get x equals negative 8, and x equals positive 2. Do I need to check my answers? Yes, that was an even index. So let's see, does negative 8 plus 6 equal the square root of 6 times negative 8 plus 52? Well, negative 8 plus 6 is negative 2. If I remember, I can't have a negative number equaling a radical, but I will work it out the rest of the way just to make sure. Negative 6, or 6 times negative 8 is negative 48 plus 52. So I get 4 over here. Does the square root of 4 equal negative 2? No, it equals positive 2. So I have to drop out x equals negative 8. Let's try 2. Does 2 plus 6 equal the square root of 6 times 2 plus 52? Well, 2 plus 6 is 8. Over here, 6 times 2 is 12 plus 52. 12 plus 52 is 64, and the square root of 64 is 8. That one does check out. So 2 is my only good answer. Okay, again, sorry about that misstep. 6 times 6 is 36. All right, 23. Same exact type of problem again. 7x plus 28 under the radical equals x plus 4. My radical is by itself, so I can go ahead and square both sides. 7x plus 28 equals x plus 4, x plus 4. So 7x plus 28 equals x squared plus 4x plus 4x plus 16. 7x plus 28 equals x squared plus 8x plus 16. So again, I have an x squared, so I move everything to that side so that I can factor. So I'm going to subtract 7x, because those are like terms. I'm also going to subtract 28 because these guys are like terms. And that leaves me with my 0 over here equals x squared plus x. 16 minus 28, I believe, is negative 12. So if I were to snowflake that, negative 12 and positive 1, I think we have a negative 3 and a positive 4. So 0 equals x minus 3, x plus 4. So I get x equals 3 and x equals negative 4. Let's check our answers. Does the square root of 7 times 3 plus 28 equal 3 plus 4? Checking 3 first. So that would be square root of 21 plus 28. Does that equal 7? Well, 21 plus 28 is 49. Does the square root of 49 equal 7? Yes, it does. So x equals 3 is good. Let's try negative 4. Does the square root of 7 times negative 4 plus 28 equal 0 plus 4? So that would be the square root of negative 28 plus 28. Did I just say 0 plus 4? I meant negative 4 plus 4. Does that equal 0? Well, that's the square root of 0. Does that equal 0? And yes, the square root of 0 is 0. So that one also checks out. So I actually have 2 answers that check out. Okay. All right. 24, the last radical one, before we get into some exponentials. So I have 3 radical b plus 1, I'm sorry, b minus 1, equals 6. How do I get rid of that 3 in front? Well, I'm going to divide by 3. So that gives me the square root of b minus 1 equals 2. 6 divided by 3 is 2. Now I'm ready to square both sides. Sorry, let me get that mouse out of the way. I'm going to square and square. So I get b minus 1 equals 4. Add 1. And I get b equals 5. Do I need to check my answer? Yes, my index is even. So let's see. Does 3 times the square root of 5 minus 1 equal 6? Well, 5 minus 1 is 4. Square root of 4 is 2. Does 3 times 2 equal 6? Sure does. And that's a pretty quick problem right there. All right, let's get into the exponent ones. 25. 64 equals 1/8 times 62 minus b to the 3/2 power. Am I going to need to check my answer on this one? Yes. How can I tell if the index is even when I have an exponent that's a fraction? If the denominator is even, then your index is even. So my denominator is even, I will have to check this. Now, before I can solve this, I need to get rid of that 1/8. So if I have a 1/8 in front there, I can either divide both sides by 1/8, but if you think about it, when you divide by fractions, you never actually divide fractions. You end up multiplying by the reciprocal. So why don't we just start off by multiplying by the reciprocal, which would be 8/1. Keep in mind, if that was a negative 1/8, my reciprocal would be -8. Reciprocal simply flips the number. It does not actually change the sign of the number. So on this side, I have 8 times 64, which is 512. And over here, I have parentheses 62 minus b, because those guys have canceled, to the 3/2 power. Now I'm ready to raise both sides to a power. What power am I going to raise both sides to? The reciprocal power of what's there. So that's 3/2. I'm going to raise them to the 2/3. Now, 512 to the 2/3. I should be able to do that on my calculator. Go back to my pink one. Let's see. 512 to the parentheses 2 divided by 3 power is 64. And then over here, I have 62 minus b. Well, if I subtract 62, I get 2 equals negative b. Divide by -1, and b equals -2. I do need to check my answer, though, so let's go back to the original problem, which was 64. Does that equal 1/8 times 62 minus b, which I'm saying is -2, to the 3/2 power? Well, let's check. 64 equals 1/8 times 62. This becomes 62 plus 2, which is 64 to the 3/2 power. What is 64 to the 3/2 power? You can do it on your calculator, or you can recognize it that it's the square root of 64, which is 8 cubed, which is 3/2 power, 512. So now my question is, does 64 equal 1/8 times 512? And it does. So my answer is good. Okay. All right, down to the last two. 26. Let's see if I can fit this down here. 4 equals 2 plus x plus 5 to the 1/4 power. Again, that denominator is even, so I will need to check my answer here. I'm going to go ahead and subtract 2 because I got to get that exponent thing by itself before I can do anything. So 2 equals x plus 5 to the 4th. And what am I going to do to both sides? I'm sorry, not to the 4th, to the 1/4. I'm going to raise both sides to the reciprocal power. What's the reciprocal of 1/4? 4/1, which is just, 4/1, not 4/4, which is just 4. So 2 to the 4th power, that's 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, equals x plus 5. I'm going to subtract 5, and 11 equals x. I did say I do need to check my answer because of that even denominator. So going back to the beginning, does 4 equal 2 plus 11 plus 5 to the 1/4 power? Let's see, does 4 equal 2 plus 16 to the 1/4? Let's go to my calculator. What is 16 to the parentheses 1/4? It's 2. So does 4 equal 2 plus 2? Sure does. My answer is good. Okay. All right. Last problemo on the back side. Here we go. Number 27. 2p minus 3 to the 1/2 equals p minus 3. All right, my radical thing is by itself, so I'm ready to raise both sides. I'm going to raise both sides to the reciprocal power. What's the reciprocal of 1/2? 2 over 1, or just 2. Now, this is very similar to the radical ones we were doing. P minus 3 to the second, I have to write that as p minus 3, and multiply it. That gives me p squared minus 3p minus 3p plus 9. And I'm going to combine those like terms. P squared minus 6p plus 9. So with that p squared, I need to get everything to the same side as the p squared. So I'm going to subtract 2p, and I'm going to add 3. That'll move everything over. So I have 0 equals p squared minus 8p plus 12. And let's go ahead and factor. I believe, let's see, 12 and negative 8. I think I have negative 6 and negative 2. So 0 equals p minus 6 times p minus 2. And I get answers of p equals 6 and p equals 2. Do I need to check my answer? Yes, that denominator of 1/2, or that denominator of 2, I should say, is even, so I do need to check both my answers. So I'm going to start off with 6. Does 2 times 6 minus 3 all to the 1/2 power equal 6 minus 3? Well, I know 6 minus 3 is 3. In here, that gives me 12 minus 3 to the 1/2. 12 minus 3 is 9 to the 1/2. Does that equal 3? Well, we know that 9 to the 1/2 means the square root of 9. Or you could check it on your calculator if you want to, but that does work out. So p equals 6 is good. Now let's try p equals 2. That would be, does 2 times 2 minus 3 to the 1/2 power equal 2 minus 3? What is 2 minus 3? It's negative 1. In here I have 2 times 2, which is 4, minus 3. 4 minus 3 is 1 to the 1/2. Well, what's 1 to the 1/2? That's the square root of 1, which is positive 1. If you check it on your calculator, it's positive 1. Does 1 equal negative 1? No, so that answer has to be thrown out. Okay, and that's the last problem on the Mod 11 practice test, also qualifier 1. Make sure you finish up qualifier 1 and come see me turn in qualifier 1 to get qualifier 2. Happy studying!